Okay. Okay, let me know if you can see my screen. Can you see my screen?
Yes, I've got to unmute myself.
Oh, okay, I got it. Cool. So, welcome back to the MP sessions. Today, we're going to be covering a lot of different topics, mostly about inheritance, polymorphism, upcasting, downcasting, using some of the words that the keywords that you guys have been talking about, like instance of and override. Yeah, so let's just get right into it. And then remember that you can always follow along on the course website and and the slides are on the CS 199 website here. Okay, so let's do an overview of inheritance. So inheritance is kind of just the ability for any class to extend another class and inherit its behaviors, both in methods and in the fields from that parent class. So here in this example, we've got a parent class enemy, and enemy's got help and max health and a mana and max mana. And then you've got the child class, which is a witch, and it extends enemies, so that's how you know it's a child class. And it's got its own method set up for casting a fireball. So some things to keep in mind here. The witch class can only access the data points of the instance fields of the enemy class that are public and or protected, and doesn't access any of the private variables. So that's just something to keep in mind. Right, so there are some questions about inheritance. If you don't have any, like our first set of problems are like set of questions about inheritance and why it's important and things like that. So if you have any questions about this, you can ask me now or in the chat, or we'll just keep going on and look at the practice problems.
We can keep going.
Okay. Cool. So the first set of practice problems, they're not really problems, but just to kind of get you guys thinking about what inheritance is and why it's important. So since it's just the two of us, I won't put you on the spot if you don't want to be, but the first question is, why is inheritance valuable? What are some situations that are ideal for inheritance, and what are some private fields and functions available to children? So you can answer those, unmute yourself and answer them, or you can type it in the chat, or you can take some time to think about it. Yeah.
Yeah, I guess inheritance is like valuable because like you can like connect all these objects together, I guess.
Yeah, that's a key part of it. It's a lot about reusing code and being able to essentially in code you don't want to be rewriting the same thing over and over again. So if you know that a dog class will inherit all the properties of a pet class, you're not reusing all of that code. And it makes for easier, it's more digestible, I guess.
Yeah.
And results in like fewer errors. And it also gives us some special properties like polymorphism that can be useful for specific cases. And then can you think of any situations where inheritance might be useful. So I think we talked about the pet class and maybe the shape class. Those are the most common ones that you see all the time. But are there any other specific situations where you can think of like classes and objects having inheritance properties being valuable?
There's nothing I can think of right now.
Mm-hmm.
Yeah, but I guess. I mean, like you mentioned before, like if you don't want to rewrite code again, we could use it. So I guess if you just like want to create a lot of stuff and you need to use it, like all the methods, you don't have to write so many stuff, so many code, and just
Yeah. Yeah, I was just thinking about like specific scenarios where inheritance would be useful. So for example, I think it's in the real world, a good one would be like the car objects. If you had a car class, then you might have different types of cars as being children of the car class. For example, you might have a car class and then you might have a child, the car class be like a Tesla. And a Tesla would have different properties from, of course, the Prius. And then maybe there would be another class in between the car class and the Tesla class and the Prius, which is kind of the electric car or hybrid car class. So yeah, that's kind of a real world example that you might consider. And you can also think about certain buildings, like you might have the general building class and then have a child class of the building class be like skyscraper or library or suburban home, something like that. Those are just examples of inheritance and why classes are valuable. You can see that like they're part of kind of our real world, and so it's very easy to apply those things into programming and coding because there's kind of a real world use case. Okay, and then the last question I kind of answered earlier, are private fields and functions available to children?
yes.
Private
Wait,
fields and functions,
they
yeah,
are they?
yeah.
Okay.
No, they're not.
Yeah.
Protected and public fields are by default available to children, but private is not. Okay, great job. We'll just keep on going. Just stop me anytime you have questions till we get to like the coding parts and stuff. Right. And then the other thing that we talked about was object, the common ancestor of all the objects, all the classes. So they have all objects inherit certain methods from the object class. The one that's talked about the most is the toString method. And there is a certain family tree associated with any kind of class hierarchy, which we'll take a look at on the next slide. And just at the top of that family tree will be the object class. So let's just take a look at an example of kind of this family tree. So of course you've got the object class, the Java default object class, and it's got some certain set of behaviors like toString, et cetera, that all objects will have. So then the enemy class inherits all of the behaviors of the object class, but it's more specific for enemies in the sense that it's got like some health, it's got some mana, and that's pretty much it, I guess. And then you have certain types of enemies, and those are some children of the enemy class. We saw the witch class earlier, but in this tree you have like the dragon, the goblin, the necromancer, and they all have their own specific abilities, methods, and instance fields defined. And so you can always think of the class hierarchy in this kind of structure, especially when you're trying to figure out what functions are applicable for a specific class. What can I call on a specific class? Can I call stab if I am an enemy object? Can I call raise dead if I'm a necromancer? So if you're thinking about this, it's always useful to have this kind of picture in your head about what attributes the children has access to, like fly and bite are available to a dragon, but a hydra also has the ability to breathe ice breath, I guess. Yeah, ice breath. Right, so there's some questions here. The first question is, what does the traversal path look for a necromancer object trying to request help? So if you wanted to access the help, where would what would the traversal path look like for a necromancer?
It would be just like from the enemy. It's just called the function from its parent, which is enemy.
Correct. Yeah. So health is in the enemy class, which is the direct parent of necromancer. So it'll go up and check if enemy has it, and it finds it, and then it will use it. So now if health was defined also in the necromancer class, it would just stop at the necromancer class and it wouldn't traverse up the tree to figure out what enemy defined health to be. And then the second question is, what does the traversal look like for Hydra object to call stab? So where's the Hydra? So here's this Hydra object. Any ideas on where it would have to go to find the stab function?
I think it can't call the stab function because it's not connected to Goblin.
Yeah, that's correct. So Hydra is got the ice breath, and so this is how Java would look at it. Java would say, hey, does the Hydra have stab? No. So let me go to Dragon. Does Dragon have stab? No. So what is Dragon's current enemy? Does enemy have stab? No. And then it goes to object and it says, does object have stab? And object doesn't have stab. So it's going to throw an error actually. And it'll just be like, I think you might get like a compiler error. Yeah, you'll get a compiler error if you try to call stab on Hydra. And don't get confused that Goblin is here, and Goblin's got the stab ability. So you might think Goblin, because Goblin is a child of enemy and Hydra is a child of dragon, which is a child of enemy, that there is some sort of relationship here, that they share some quality because they don't. So that's just something you want to watch out for. It can be misleading just because it's above Hydra to just assume that it has the qualities of Goblin. So I think you understand the general gist of it. You're traversing the tree to figure out what functions you can use, what attributes you can call. So next, let's take a look at polymorphism. So polymorphism we've covered 2 days ago, and it's the gist of it is like many forms, right? That one class can have many different forms. So in this example here, you've got the pet class, which is an object, because above the pet class, the parent is the object class. And then you've got the dog class, which extends pet. So when you have the extension here, you know that the dog class is also a pet class and it's also an object. So it's got these properties defined there. And then mutt extends dog. So mutt's got this dog. Mutt is also a dog. Mutt is a pet, and mutt is a object. So because it's inheriting these properties, it's also able to take on these very same properties. And that's hence the word polymorphism, multiple forms or multiple objects. Okay, so here's some practice. So you're just being asked to go through this code. You've got a set of classes here, a set of inheritances. So which one of these is acceptable for us to pass into each of these functions? So if you've got foo and foo is taking an object, which of these classes could you use in this function call? That's kind of what you're being asked to figure out. You could take some time, take 5 minutes, just take a look at it and try to figure out which classes can be called, and then we can kind of talk about it in 5 minutes. Or you can let me know in the chat if you want.
Okay. Yeah, I think I can just try to answer it now. That's okay.
Okay, yeah, great. So for foo, what do you think? What's acceptable?
Since object is like the superclass, then I guess any object could be used as a function.
Yeah, exactly.
And
Yeah, superclass has got access to everything. What about Voo?
the Vu jetliner J, so everything that is below jetliner. Oh wait, just the Airbus A380.
Yeah, so jetliner and Airbus
Yeah,
A3. Yeah, that's the two.
just those two. And then for UFO, it would just be UFO. Because nothing else is
Yes. Yeah, it doesn't
extends.
have any children.
And
Yep.
flying object is basically everything in here.
Right, because it's kind of the overarching class for everything. Yep.
Mm-hmm.
Yeah, it looks like you nailed that on the head. Yeah, so when you're asked these kinds of questions on a quiz or anything, just remember to check either traverse the tree in your head to figure out what's an applicable object to pass in here, or think about it in terms of the class name and all of its children could potentially be acceptable. Great. So now we're going to look at upcasting and downcasting. So upcasting, very easy, straightforward to do. Let me just talk about what's happening here, right? Like you've got, in this example, a new jetliner you're creating, but then you're upcasting it into a flying object. So it's kind of different from what we've seen thus far with this kind of two different types. You've got a flying object on the left side, you've got a jetliner on the right side. The reason why it's called upcasting is because you're going from this child class and you're going up in the tree, essentially going up to the flying object, and you're upcasting it like that. Remember that when you're doing upcasting, that the functions available to my private jet are dependent on the functions available to flying object and jetliner. So if I tried to call something that was only available in jetliner, it would give me an error. Yeah. Let's see if I can demonstrate that. Okay. All right. So you've got my private jet, which is a flying object, and then you've got jetliner here, and let's say that flying object has some function in it. We'll call it, what should I call it? Fly? Yeah, fly. Okay, so fly, and maybe a little bit cool. Or not, return flying object. And what we'll actually do is let's put this in here inside of jetliner. Where's jetliner? Here it is. And instead of doing this, we'll call this jetliner. We'll do the call fly. Okay. Okay. So when you call it like this, it has no problems calling the fly method. It just goes in and it says, okay, you're a flying object that's actually a jetliner hidden underneath. Let me go see what jetliner has defined for fly, and it prints out this, okay? Great, so that works exactly how you'd expect it to. So if I had removed this, for example, though, let's just do this. Okay, so I commented out, now jetliner doesn't have the fly method anymore. So if you run it, it goes in here and it checks to see if jetliner has a fly method. It doesn't, so it'll go into flying object and see if flying object has it. Flying object does have it, so great. So just prints out flying object. So what about if I didn't have fly inside of flying object? Do you know what will happen?
It would print jetliner.
Yeah, no, it actually doesn't. So remember that when you're upcasting something, that this side of the upcast essentially determines what methods and functions your object can call. So even though my jetliner object actually does have the fly method, because all flying objects do not have a fly method, you can't call fly on my private jet. So you can only call the functions that are accessible to all flying objects and not unique to jetliner. Because you can have other flying objects, right? If this was an airplane, for example, and you tried to call fly on it, it wouldn't work.
Oh, okay, got it.
Yeah. Yeah, so always keep that in mind when you're doing these upcasting things. Okay, so downcasting, great. Downcasting is just opposite of it. Basically, it allows you to take the higher level class and convert it back into a lower level class. And all you got to do is if you got to make sure you got to check that there's an instance of, and then you just do it. This is the syntax for downcasting. You put it in parentheses and you can reset it, and then you can call it to whatever you want. So in our previous example here, where we're calling the fly method, what you can do to avoid this issue is you could downcast my flying object back into a jetliner, and then you could call the fly method. So if you did something like this. Yeah, so it'll check if it's an instance of jetliner, and then if it is, then we'll get it to do this. sorry, method dot methods. Okay, so here we're able to call the fly method because we've downcasted my private jet into a jetliner, and jetliner can fly. So that's the cool thing about upcasting, downcasting, allows you to access different methods and variables based off of what you're casting it into. Just a useful trick to know.
I have a question. Do you always
Yeah,
have to do the instance of inside an if statement? Can you do it
yeah, I'm
outside
pretty
of
sure
it?
you do. Yeah, you
Got it.
do. So if you're gonna do like the one-liner, then you do need the instance of. Um, you can also do it in like the two-liner, which is the if statement, and then downcasting. So yeah, you always want to do the instance of whenever you're going to do this. Cool. So first, programming practice problem. Okay. So you're going to be doing some upcasting, instance of, override, things like that. We're going to be comparing two different enemy objects, and we're going to check to see if they have the same max health and the max mana. And then we're going to write an equals function inside the enemy class that will compare to make sure that that two enemies are the same or different. Okay, so here's some starter code. You got two enemies. Your goal is to write the equals function that will check if these two enemies of any child class of enemy, it could be dragon or griffin or anything else, check to see if they are equal to each other. We check to see if they're equal by checking the max health and the max mana. So I'll give you about 10 minutes if you want to work on this on your own, and just let me know when you're done programming it out. Or
Okay.
yeah. Okay, so we'll regroup at 6:42. Okay, looks like you're done. Yeah, I'm looking at your code that you had put in the chat. It looks right. Yeah, that looks right. But I'm gonna go ahead and review it just for the folks who are either watching the recording, don't know how to do it yet. Yeah, okay. So there's some nice pseudocode here that should make things a little bit easier. But basically, you want to check to make sure that O is an instance of enemy, because obviously two enemy objects can't be equal to each other if they're not enemy objects. So then what you want to do is you want to downcast it, downcast the object into an enemy. These are bad variable names, but we're going to go with it. And then you want to check to see if the max health of the enemy object that you just downcasted to is equal to the max health of the current object that you're comparing with. And then you also want to check that the max mana is the max mana of this. Okay. Right. And if everything is, if that's true, then sure, that you would return false. Yeah, you actually want to return false up here. Yeah, and that should work. Good. Okay. Any questions on that before we move on?
I'm good.
Okay, cool. Well, that is a fairly easy problem, especially since we just covered instance of and everything. So here's a slightly more challenging problem, I think. Right, so in this question, we're asking you guys to create a constructor for this goblin class, which retrospectively, now I'm thinking it's not a more challenging problem, but you're going to create a constructor that has that will copy the given goblin object into the current object. So if you take a look at this code, I guess this part of the code is a little bit more challenging than the other part. But what's happening here is you're creating a new goblin instance, you're assigning it to have some class and some weapon. Then you're creating an army of goblins that has some sort of size, 100. And then what you're going to do is you're going to go through this army of goblins and you're going to initialize what each goblin looks like. And you're going to base that goblin initialization based off this original goblin. So that's what's happening here in this snippet of code. So this part should be pretty easy, but we'll do like 5 minutes to go over that. Let me know when you figure it out.
Do you just put like for your code here? You just put like clan equals to c dot clan and weapon equals to C dot weapon.
Yeah, you just set the clan and the weapon essentially.
Okay.
Yeah, it's pretty straightforward, I think. So it'd just be this dot clan, C dot clan, and this dot weapon, this C dot weapon. Yeah. Yeah. Then going to this also. Yeah, so that's it. Right. So covered a lot of stuff. I know it's a little bit earlier than usual. I think it's the first time that we've ever finished before 7. So what did we cover today? We did inheritance, why it's important, what it is, why it's important, examples of it. We talked about polymorphism. What does that mean? And what does it mean in the case of upcasting and downcasting? What properties does an object have when you do upcasting and downcasting? And we talked about how to use instance of and override. I get this question a lot about override. Let's see, where did we use override? We used override. Yeah, so for this code right here, this is an override. You're overriding the equals method that is available to all objects. So when you're overriding something, the question I always get is, do you need to use the @ override keyword? Let me show you what I'm talking about. Right. So if you implemented this, I always get the question, do we need to do this override here? It's just to let the compiler know that this is going to be an override. It's not necessary, and you can leave it off and it'll run fine. But in clean code, you typically want to include the override at the top here so that people know that you're overriding something and that it's just clear to read. So yeah, that was kind of the example of override, which I guess I missed on as we were talking about it. But we also talked about copying objects using constructors. Fairly short lesson today. So any questions? I think that's all we have for this week. I mean, it's the weekend, so I guess you can go chill, do whatever you want to do.
Yeah, I have no questions.
Okay, cool. Yeah, if you got feedback for us, let us know on the website. There's a feedback form. Have a good weekend.
All right, thank you, Akhila.
Mm-hmm.
Bye.
No problem.